A confirmation about the audio, please, guys. If the audio is available and is clear, kindly confirm. Thank you. So, any doubts that we have had till now in the portions that we have covered, any doubts that prevail, any kind of doubts which happen, let me know. Or is it something which is clearly understood, all of it? Kindly let me know. Because it is important to solve the questions and the doubts the moment that they appear, not at a later stage. So that is why. Okay. So I assume that the doubts do not prevail. So now we move on. Why a current is named after Peru? So the currents are basically named after the regions that they come from. For example, Labrador's current is named after the Labrador Sea. Canary current is named after the Canary Islands which are present. Same Brazil current is named after the country of Brazil. So like that, you have Falkland current named after the islands which are present there. So that is why you have that. Other than that, any other kinds of doubts if you have. So here, now we come to the portion of the Pacific Ocean. Now, Pacific Ocean also ends up experiencing and exhibiting a similar kind of, it will also end up exhibiting a similar kind of motion that we have observed, that we see in the case of Atlantic Ocean. Okay, so when we talk about the Pacific Ocean, here also few things that you have to keep in mind. Same is the case with Atlantic, and for every ocean current you have to keep in mind, first of all, in the step by step procedure, if you think about it, then the waters will get significantly accumulated and heated up in the region of equator. So firstly, water at equator gets heated up and gains a height gradient. Height. Then after that, winds in particular. Which winds? Trade winds. Because around the region of equator, we have the prevalence of trade winds. So the trade winds are the ones that you will find in circulation. So trade winds, right, carry the water from west to east. Right? Some part of the accumulated water will flow back due to the rotation of the planet from west to east. That induces that flow back. So some of the accumulated water, here it should be east to west, not west to east. Okay, some part of accumulated water drains back or flows back as counter equatorial current. Okay, partially aided by the rotation of the planet. Aided by the rotation from west to east. And then after that, water in the northern hemisphere bends to the right and in the southern hemisphere to the left. So just use these set of basic principles, and thereby you will be able to understand what happens in the region of Atlantic and what happens in the region of Pacific Ocean also. So we have seen the portion of Atlantic. Now we will follow the same principles and we will get a clue about the oceanic circulation in the region of the Pacific Ocean also. So when you take a look at the Pacific Ocean, here you will come across the fact that significant amount of warm water ends up developing around the region of equatorial Pacific, significantly around the region of equatorial Pacific. Now this warm water is drained or is pushed to the westward side because of the prevalence of the trade winds. Now these trade winds, they will carry the water all along to the western portion of the Pacific Ocean. And that accumulation of warm water in the western Pacific initiates what kind of atmospheric phenomena? Let me see if we recall anything from the previous ones, or are we still a kind of a passive ones where whatever is being taught is okay. So let me know if you have the accumulation of warmer waters in the region of Pacific Ocean, what kind of atmospheric phenomena is triggered by that? What do you think? No, Abhijit, that is incorrect. Anshu, that is correct. So basically, it induces the Enzo cycles and brings about the Walker circulation, which magnifies to bring about La Nina conditions. Right? So generally, you have Walker circulation and La Nina conditions due to this water being carried all the way to the Western Pacific. So here, what do you observe is that this water is carried all the way to the region of the Western Pacific. And when it reaches the region of the Western Pacific here, after that, significant portion in the northern hemisphere, they will start bending to the right owing to the Coriolis force. Now here, the region of Japan will have the division of water. One will move from the eastern portion, other will move from the western portion of it. So that creates the Kuroshio and the Tsushima current. And this Kuroshio current is very similar in terms of the similarity in terms of where it is found. It is very similar to the Gulf Stream that you observed. Right. Now, here in the case of Gulf Stream, we had colder waters joining from the higher latitudes, that is the Labrador current. In this case, you have the colder waters joining from the northern latitudes, higher latitudes, that is the Oyashio current. So this will also end up forming a very rich, a very fertile fishing ground. So very rich fishing ground because you have mixing of warm and cold water. Fishing ground. Then furthermore, this water is then carried with the help of the westerlies in the direction from west to east. It is aided in its motion with the help of westerlies. The westerlies will be able to carry it further forward. And then as it hits the American coastline, this water gets bifurcated. One part moves to the north to form the Alaska current, and the other portion moves to the south, forming the cold California current. So the same water will generate a warm current, and here it will generate a cold current. Why? Because here it is moving from lower latitudes to the higher latitudes. Here it is moving from a higher latitude to that of a lower latitude. So that is why it brings colder waters from the higher latitude, and hence it is a cold California current. Here also you will come across the same situation, that the colder currents are found on the western coast of the continents in the lower and middle latitude. So that is how you have the entire generation or circulation of water observed in these Pacific Ocean, North Pacific. When we talk about the South Pacific, Now here, the water which had come up till here, some part of that water actually ends up leaking through. Some part of that water ends up leaking through into the region of Indian Ocean. And that is what is also referred to as Lewin current. Lewin current. And that is what supplies the water from the region of the Pacific all the way into the region of the southern Indian Ocean also. But that is not a major chunk, a very small portion. In the meanwhile, the other portion here, you will have them turning to the left, and that is going to form the East Australia current, because from the eastern part of Australia, it will mix with the west wind drift that is to be found in the Southern Ocean across the entirety of the globe. The circumpolar current that you have across the entirety of the globe, why? That is not to be found in the Northern Hemisphere, it is only to be found in the Southern Hemisphere. And the reason, prime reason for that is that when we talk about the Southern Hemisphere, all around the region of Antarctica, you have a uniformity of water body, a significant uniformity of water body. And that basically means that you have a uniformity in terms of the motion of the water, the movement of the water, that is more or less uniform. So that is why you have this wind influenced by the westerlies, and that is referred to as the west wind drift to be found in the Southern Ocean. This west wind drift, in the case of the Atlantic, took a leftward turn to form the Beniguela current. Here it will take a leftward turn to form the Peru current, the cold Peru current. So that is how it brings about the entire circulation in the region of South Pacific. Okay? Is that understood, or do we have any doubts here? It is very much similar to the case of Atlantic. Atlantic and Pacific Ocean, for that regards, are very much similar because they end up following the same principles. And the same principle is observed even in the case of Indian Ocean, the Southern Indian Ocean. Northern Indian Ocean is different. Why? Because when we talk about the Northern Indian Ocean, here the impact of the wind will be predominating. So when we talk, let's say, about the Indian Ocean, here in the case of Indian Ocean, the northern portion of Indian Ocean will have a reversal of the current because of the reversal of the wind movement. So, North Indian Ocean experiences a reversal in the wind movement between seasons, leading to a reversal in ocean currents. This is not to be found in any other part of any ocean other than the North Indian Ocean. That is what makes the North Indian Ocean a very unique and peculiar case. This was asked by UPSC, and this has been asked by UPSC multiple times in the mains examination, where UPSC, both in the optional as well as in the portion of the GS, where UPSC has asked this to the candidates, that why is it that in Indian Ocean or North Indian Ocean you have a reversal of current, or explain the role of wind in formation of the ocean currents, taking the example of North Indian Ocean. So these kinds of examples or these types of questions you can always expect. Wherever there is a kind of an anomaly which is at play, that becomes relevant for your exam. So here in the Northern Indian Ocean, when we talk about it, so during the months of, let's say, June, July, August, and so on. So you will observe that the wind motion is southwest to northeast, and that carries the ocean current in that direction. So that is where you will observe that in the Northern Indian Ocean, the circulation observed during The advancing monsoon is what? It is clockwise. Whereas the circulation observed during the time of the retreat of the monsoon, or rather even the northeast monsoon, in the months of December, January, when the wind direction completely reverses itself, so the movement also will be significantly and sufficiently reversed. So that is where you will have a kind of a counterclockwise movement of water in the northern Indian Ocean. Okay. Now, after this, here basically in the southern Indian Ocean, the aspect is very same and it is very similar to the southern oceans of all the various different parts of the globe. So here you will observe the south equatorial current being pushed in by the trade winds. Now they get divided by the Madagascar. You have the Agulhas and the Mozambique current. Then they will also be turning to the left. They will be meeting with the west wind drift. And here again, the west wind drift earlier would be deviating to the left to form the Peru current, would be deviating to the left to form the Beniguela current. Here they will be deviating to the left to form the cold West Australian current. West Australian current would be formed, would be created by this. So that is why you have the cold West Australian current, which is formed. And meanwhile, the Lewin current is the movement of water from the Pacific into the portion of Indian Ocean. Okay. West wind drift comes from higher latitudes where the west wind drift, basically, when we talk about the southern hemisphere, that west wind drift is to be found in the Southern Ocean. And that is aided by the continuous motion and movement of the westerlies. Westerlies are particularly strong in the southern hemisphere as compared to the northern hemisphere. So that is why the westerlies, they end up bringing that kind of a circulation. And southern ocean because it is generally cooler, so hence it will have a comparatively cooler current. And yes, some portions are brought from further higher latitudes with the help of the polar easterlies. They also bring some amount of water from the higher latitudes around the region of Antarctica. That makes it further colder. Okay. So now after this, we come to the portion which has been in discussion of current affairs for the past couple of years, more prominently so, and that is Atlantic meridional overturning circulation. Now, Atlantic meridional overturning circulation, this is also what is referred to as AMOC, the short form of it. There is no other larger meaning behind it. It is the simple short form. Now, here in front of your screen, the image that you see, that is basically of a circulation which is initiated, which is observed across all the oceans. A circulation which is initiated where you will observe that warmer waters, they basically move to the higher latitudes where their density increases. The same principle of a thermohaline circulation is at play. The water sinks to the lower level. It starts coming back. Okay. And then eventually it will circulate across the various different oceans. And then whenever it gets heated up, the density will reduce. It will start rising to the surface. It will then form a surface flow. Meanwhile, in the subsurface, it also enters into the region of Pacific Ocean. Again, getting heated up. Again, it rises up and you have a surface movement. For example, this portion that you see over the region of Atlantic, this work is done by the Gulf Stream. Okay, that work is created or done by the Gulf Stream. So that is basically leading to the mixing of the oceanic water across the oceans of the entirety of the world. This is what is primarily also referred to as the global conveyor belt. Global conveyor belt. Now, I hope we understand the meaning of a conveyor belt, what is meant by a conveyor belt. So when we talk about a conveyor belt, it is basically a kind of a circulation that you observe. right? So let's suppose you would have seen the escalators when you are moving to, let's say, a mall or the railway stations or the airports. You would observe that there is a kind of a circulation of a belt, right? So that is a conveyor belt used in industries, in flour mills, etc. This is a conveyor belt. So this entire portion is also what is referred to as a global conveyor belt. Now, this global conveyor belt ensures, again, the same thing that is carried out by the thermohaline circulation. This entire conveyor belt is nothing but a large thermohaline circulation observed across all the oceans of the world. So, this is basically a large scale thermohaline circulation. Large scale thermohaline circulation. And its role is also the same as attributed to the thermohaline circulation: distribution of heat as well as the distribution of nutrients. That is why this conveyor belt's movement is very important for maintenance of temperature of the global oceans. Now, for this conveyor belt, when you consider the region of the Atlantic, let's suppose if I consider the region of the Atlantic Ocean. So if you just isolate that image of the only region of the Atlantic, you will observe what? That in the region of Atlantic, you have the water which is moving to the higher latitude, it is sinking and is coming backwards, right? It is coming to the lower latitude again. It can rise up depending upon if the water heats up significantly, it can rise here itself. Otherwise, it will go to the southern Atlantic. It might rise up here also. So in this, you have the overturning of water because of difference in temperature and salinity conditions. So that is why this particular portion is of the global conveyor belt is what is referred to as the Atlantic meridional overturning circulation, because it is happening over a particular meridian. Over there is not much amount of longitudinal change which happens. So that is where the water is overturning, initiating a circulation, and hence referred to as Atlantic meridional overturning circulation. The region of SA is cold. Utkarsh. Region of South America, if you are asking, is that what you mean by the question, Utkarsh? Okay. So basically, here observe this portion which is cold. It is the subsurface water, my dear friend. This is the subsurface water. And this on top of it, this is the surface water that you have. So the surface water will be heated up. The subsurface water will be particularly cold in general. Okay. If that was the doubt, or is the doubt something different, please kindly clarify. So here, when we talk about the global conveyor belt, it is a system of ocean currents that transport water around the world. While the winds primarily propels the surface currents, deep currents are driven by difference in terms of water densities, which is in a way dependent on temperature and salinity conditions. And that is what is referred to as a thermohaline circulation, because that is dependent on both temperature as well as salinity of the water. Now, across this conveyor belt, heat and nutrients are moved around the world in a very leisure 1,000-year cycle. So for that entire conveyor belt to play out, for let's say a water which is present here to return back to this region again, it will take close to around 1,000 years overall to have that entire circulation to be achieved. So that is how slow it is. But it has been in news because in the recent days, it is further slowing down. So basically, when we talk about AMOC, Atlantic meridional overturning circulation, so the Gulf Stream is a major part of this AMOC. Now, as warmer Gulf water approaches the North Atlantic, it cools, releasing its heat to the atmosphere. As it cools, the water becomes more salty and dense, and sinks or overturns to the bottom of the ocean. The Gulf Stream and AMOC are a part of the ocean conveyor belt in general. At the intersection, we find both cold and warm current. Which intersection? Which intersection do you find the presence of both cold and warm currents? Utkarsh, I'll come to it. But I have a question that at intersection we find both cold and warm currents. Which intersection do we find the presence of? Here. This one. This is not the existence of cold. See, this is the subsurface current. Subsurface means what? Underwater at a particular depth, right? So when you have that underwater, it will always be colder. There is no intersection. This is simply hidden behind the surface. Here you don't have an intersection of cold and warm current. This is moving at a surface. This is moving at subsurface. So there is a height difference between them, right? One is moving at a surface which is warmer, other one is moving at the subsurface which is colder. Similar to what we observed in the thermohaline circulation. What did we observe in thermohaline circulation? That warmer waters will move on the surface, colder waters, when the warm water becomes cold, it sinks and then moves at the subsurface. Okay. So that is basically your global conveyor belt and AMOC. Okay. So AMOC basically is the Atlantic Meridional Overturning Circulation, which is a part of the global conveyor belt overall. And it is observed in the region of Atlantic Ocean primarily, where you will observe that warmer waters, from the simple logic that we have applied in the thermohaline circulation, the same logic will be applied here. The warmer waters go there in the higher latitudes, they lose the temperature, they cool down, they sink, and then they continue their motion underwater. So that is basically the AMOC. Now, AMOC has been in news. Why? Because this AMOC is slowing down. This AMOC is slowing down. Now, what is the result of this, or what is the outcome of this if this AMOC is slowing down? So when the AMOC is slowing down, and why it is slowing down? So understand this. So here, when we talk about a particular region, let's say the Atlantic Ocean, and let's say this is the north, this is the region of equator. Okay. So here you will have the presence of warmer waters around the region of equator. Now, these warmer waters ideally indicate a movement towards the higher latitude because of the height gradient that they have. And then when they move to the higher latitude, they will eventually cool down because they have reached a region of the higher latitude which is very cold. That is why they will also cool down. And it is then after cooling down that they would sink or they would overturn. After cooling down, they would sink and then they would overturn to have a circulation. Isn't it? That is what we have seen. Now, that is what should happen under ideal conditions. But the world is changing. The climate is changing. The globe is warming. So when we have the entire planet which is warming up, so that means what? Even the higher latitudes are warming up. So here, because of the global warming, the higher latitudes, they start warming. Okay, so let me write it down. Due to global warming, higher latitudes are heating up. Now, when the higher latitudes themselves are heating up, that means what? The water which was cooling down after reaching the higher latitude, will it cool down at the same rate? No, it won't cool down. So if the water doesn't cool down sufficiently, it will not overturn as well, isn't it? So you will have limited overturning of the water, right? So because of the warming, the water stops to overturn, it doesn't overturn. That means the water will stay where it is. There is a lack of overturning, so the water will stay where it is. And if the water stays in the same region for a long time, it gets heated up by the solar insolation. And when that water, whenever you have oceanic water getting heated up by solar insolation quite significantly, which atmospheric phenomena is resulted as a consequence? What do you think? Let me know. And what does that lead to, Ambika? What does that low pressure lead to? So, how many of us have not revised the previous portions that we have covered? Now you are throwing random objects as an answer. Okay. So, many of us have not revised. Okay. Fair enough. Question again. Okay. So, I will ask another question. How many of you have had so hearty a lunch that we are feeling very sleepy in this session and our minds are not working? Because this is the second or the third time that I've been asked to repeat the question that I'm asking in the session. So, how many of us have had such a hearty and a heavy lunch that we are unable to open our eyes anymore? And we have no clue what is going on in the class. It might well be geomorphology, oceanography, as long as it is geography. I'm sitting in the session and somehow I'm doing my job that will help me clear the civil services because I have attended the session. Okay, good. Few of you are honest enough to raise your hands. Okay. Basically, the question was that when you have the AMOC slowing down, so that AMOC, when it slows down, it will instigate a stability in terms of water. Water will not be overturning anymore, as a result of which the water will get heated up quite sufficiently in the same region. And when water gets heated up at the same region significantly, so you had Vishal and Sian who gave the correct answer. So that creates an extreme low pressure, and that gives rise to the formation of tropical cyclones. So that is how tropical cyclones are basically generated. That is why the region of Atlantic, if you will observe, that has had an increased impact. And in the region of Atlantic, you had increased frequency of hurricanes. Cyclones are referred to as hurricanes in that part of the world. So that is where they are referred to as hurricanes. And you have increased frequency of hurricanes in the region of Atlantic Ocean because of the slowing down of AMOC. This is a very important portion for your part of mains examination as well as for your prelims examination. There is a high probability that UPSC is going to frame a question from this in the mains exam. So when we talk about the ocean conveyor belt, it describes the interaction of surface currents like Gulf Stream and deep, slow moving underwater currents across all the ocean basins. These interactions, they mix the ocean waters, salts, and even organisms at a global scale. As ocean temperature and density contribute to the temperature change in the atmosphere, the ocean conveyor belt also contributes enormously to the climate on our planet. So here also understand one thing. When the water in the AMOC would cool down upon reaching the higher latitude, that water would be losing heat to the atmosphere. And that would bring rainfall in that region. But with the slowing down of that water, that heat is not released to the atmosphere anymore. That is why the region of North Atlantic is turning out to be much drier. And that is why you will experience the frequent occurrences of heat waves in the region of Canada and Europe. For the past couple of years, we have had very frequent heat waves in that region because of the slowing down of AMOC. Now, Then we come across to the impact or the effects of ocean currents. So when we talk about the effects of ocean current, they have a wide ranging impact, not only in terms of the oceanic water, but also in terms of temperature and the geomorphology of the region around. For example, when we have the mixing of warm and cold ocean currents, wherever that happens, this creates ideal fishing grounds. So, the best fishing grounds of the world, they exist in regions where you have warm and cold ocean currents meet. So, for example, in the region of North Atlantic, we have the mixing of the Gulf Stream and the cold Labrador current. In the region of North Pacific, we have the mixing of Kuroshio and Oyashio. So these can be cited as examples. Gulf Stream and Labrador Current, Kuroshio and Oyashio. Okay, these are your ideal fishing grounds. Now, these you have we have all seen that you have the presence of cold ocean currents in the western margin of the continents, and these cold ocean currents in the western margin of continents, they also end up creating deserts across the western margins of the continents. That is why in majority of the continents on the western margin you will find the presence of deserts. How and why? So for example, here if we consider a landmass, let's suppose we consider a landmass in this region, and here you have the prevalence of water, right? Now in case you have a cold current, means the temperature is going to be very low. Temperature is very low, and that means you will have very low temperature of air in this region as well, whereas above that you will have warmer air on top of it, warmer air on top of it, and this leads to a condition of temperature inversion. Temperature inversion. And in this case of temperature inversion, it means lack of rainfall, absolute lack of rainfall. And whenever we have an absolute lack of rainfall, that brings about desert condition, creation of deserts. That is why we will come across a scenario where, for example, in the western coast of South America, you have the presence of the very cold Atacama Desert. In the western coast of North America, you have the Mojave Desert. In the west coast of the southern part of Africa, you have the Kalahari Desert. In the west coast of Australia, you have the Victorian Desert. So majority of the deserts across the world which share a coastline, you will find that they are created because of a cold ocean current in existence. Okay, and this impact again has been asked in the examination, so you should be aware of this. Then we come across to the Sargasso Sea. Sargasso Sea, and that is named after sargassum. So basically, whenever we talk about a sea, how is a sea different from an ocean? So a sea typically designates a margin of the ocean, and it will have a boundary of the land. It is closely surrounded by land areas. Sargasso Sea is smack in the middle of the Atlantic Ocean, and it is surrounded by the ocean currents from all sides. It will have the Gulf Stream here. The western boundary is by Gulf Stream. Then the northern portion, here you have the presence of North Atlantic Drift. Then here you have the cold Canary Current. And then here we have the North Equatorial Current. Okay, so that is where you will observe that this Sargasso Sea is basically created by these various different currents. How is this created and what is it? So as these ocean currents, they end up moving in a circulation, you have to understand that they will have a limited impact in the central portion, because the ocean water are moving here. They will be bending to the right, maybe they will be able to drag some water here also, maybe some water furthermore, but not beyond that. So that is where the middle portion is also, by the way, a region of high pressure, the subtropical high pressure region. So you have a lack of wind movement across the horse latitude in that region. So here you have a lack of wind movement, you have a circulation all around where the central portion is left undisturbed. And that is where in the central portion, you will observe the development of seaweeds, the algal species or the seaweeds, right? These are your seaweeds. And these seaweeds, they are referred to as, in Portuguese, they are referred to as sargassum. Now, basically, the Portuguese explorers during the 1500s and the 1600s, they encountered this first of all. And when they were moving across with their ships, they found out that this is a region where there is no ocean current. And not only that, you had the presence of the orangish brown spread of a very large area consisting of only seaweeds. Now, this is how the seaweeds look underwater. So it is absolutely a kind of a heaven for the various marine biodiversity. Marine biodiversity, they find a kind of a breeding space, availability of food. So marine diversity will be there, good for biodiversity, but very bad for navigation. Because if your ships are moving through that area, there are chances that the hulls of the ship, the propellers of the ship, will get entangled in this vegetative growth. So it is a nightmare, very bad for navigation, impacts the maritime navigation significantly. It impacts the maritime navigation quite significantly, due to which you have significant amount of failures which are observed in terms of the hulls and the propellers of the ship. There's a breakdown which happens, and because it is enriched and dominated by sargassum, hence the name Sargasso Sea is associated with this. Okay, so that is something that you have to be aware of. So let me give you a brief summary. Even if you are interested or not, I will provide you the brief summary of everything we have studied in this portion up till now. So when we talk about it, the oceans of the world. So here, first of all, bottom relief is what we had studied. So bottom relief dominated by geomorphological features. Okay. Now, here, after that, when we say dominated by geomorphological features, we have which features? Tectonic, tectonic, and tectonic features which create which bottom relief? Ocean trenches, mid-ocean ridges, but that can also be sought to be referred to in volcanic features or volcanic activities. So you have volcanic activities that creates mid-oceanic ridge, seamounts, they are also created in this process. Then after that, we have erosional and depositional feature. and that is what creates. So let's bifurcate it so that it is easier for us to recall that. So we have erosional first. Erosional features. What are the erosional features? You have submarine canyons. You have guyads. You also have continental slope. Then when we talk about depositional feature, what are the depositional features created in the process? You have shelf, continental shelf, and continental rise. And also in deep sea plains, also you observe deposition. Deep sea plains also, you observe significant amount of deposition happening. Then after that, we studied about the physical properties of water. So physical properties of water when we refer to, so in that we have factors of temperature. Temperature depends on, you have the horizontal variation of temperature, you have the vertical variation of temperature. So when we talk about variation, you have the horizontal variation, and that is initiated by heating or latitudinal extent. Then we have the factor of wind, movement, ocean current, okay, impact of land. These are what create a horizontal variation in terms of temperature. And variation in temperature is also vertical, where we observed temperature at bottom is fixed, right? So that is why we have a zone of transition between photic and aphotic zone. That is a thermocline. So zone of transition, thermocline. Then we observe the condition of oceanic salinity. And when we talk about the salinity conditions, basically, again, you have variation. Why? Because of addition or removal of water, addition of water, and also removal of water. Addition of water brings about rainfall, rivers, melting of ice and glacier, and also groundwater. Whereas removal of water includes the regions of or portions of evaporation and freezing. And freezing. Then after that, when we talk about the variation in verticality, here also we have the zone of transition. that is halocline. So here also, when we talk about, so this, all these, they will reduce salinity. All this feature will end up doing what? They will end up increasing the salinity. Salinity rises. So then vertical variation, salinity at bottom is fixed. So zone of transition, that is halocline. Okay. Now induced by the temperature and the difference of, so when we talk about the induction, let's say, oceans. So here we consider movement of oceans, movement in ocean water. So basically, you have difference or density is dependent on temperature and salinity. Okay. And then difference in density. No, Utkarsh. AMOC is not led to the formation of mocha. Mocha is formed because of heating of the water due to the low pressure centers in Bay of Bengal. Difference in density initiates thermohaline circulation, right? Movement of water from lower latitudes to higher latitudes. Okay. Then after that, we looked at the tides as a major portion. So induced due to gravitational pull of sun and moon, as well as centrifugal force. So these tides, they are of two types based upon position of sun and moon. We have the condition of spring tide, that is observed in the situation or the position that we refer to as syzygy, and also neap tide, which is observed during quadrature. Then after that, we looked at the ocean currents. You have primary and secondary forces. So they are initiated by what? They are initiated by heating of the sun, so solar insolation. Then wind movement, Coriolis force, shape of coastline, bottom relief, etc. Now, you have the various currents in different oceans. So that is something that you can look at by the various images that we have given you. Then we have looked about the global conveyor belt that generates large scale thermohaline circulations, and also you have this carrying out mixing of nutrients and heat distribution. A part of it is AMOC, is slowing down. That is leading to the warming of the ocean. Warming of oceans. It leads to lesser heat given in the atmosphere. So heat waves, more cyclones. Then impact of currents. Here you have good fishing ground. Then you have the presence of or moderation of temperature. Impacts the temperature of a region, creates cold deserts. In western margin of continents. Okay, so these are the portions that we have studied in oceanography till now, and in a way I have given you an idea about how to prepare notes in a very brief manner. So here you can see that how the entirety of the aspect of oceanography can be reduced, can be restricted to a couple of pages of notes. Ideally, you should ascribe to that, you should try to adhere to that. This will facilitate your portion of revision whenever and wherever and in whichever year you want to go for revision, you decide finally to go for revision. These things and the methodology of making notes like this is going to help you out. And whenever you come across a complicated concept, any concept which requires a deeper thinking and a deeper interconnection, for example, the slowing down of AMOC and its impact on the atmosphere, that is a very deep concept. And from there, you can easily have a 15-mark question which can be asked separately. So that is where in those areas you can have a separate short kind of notes made from that portion as well. But this is the overall template that can be followed. Anshu, is west wind drift due to the jet streams in the southern hemisphere? No, it is due to the westerlies in the southern hemisphere. Slowing down of AMOC, how it causes heat waves? Because see, when the AMOC slows down, earlier in the normal conditions, when the AMOC functions quite naturally, as you have the water cooling down, means when water cools down, heat energy is given out. So that heat is given in the atmosphere, which initiates the cloud formation in that region. But now, because that water is not overturning anymore, it is not cooling down anymore. So that is where that heat is no longer given up, or that heat is no longer supplied to the atmosphere. So that is where you don't have cloud formation which is happening. And this has been observed across the region of North Atlantic. And when you don't have cloud formation, you have prolonged heat condition that leads to heat waves. Okay. So that is basically the portion that we have covered in the entirety of oceanography till now. Now, we can concern about tropical cyclones in South Indian Ocean. We can concern about, what is the meaning of the, please elaborate your question carefully. Now we come to the portion of coral reefs. Now, coral reefs basically is something that is covered in the portion of environment and ecology. Here we shall be covering it from the perspective of the portion of geography. So this is very relevant area from the point of view of your examination. So in this case, the questions that are asked, the questions that are appeared, they basically refer to the formation of the coral reefs in certain cases. And sometimes you will also find questions about coral bleaching and so on, which will be discussed in greater detail in the portion of environment. Here, briefly, we will be touching upon these areas. So in this case, when we talk about the corals, in the prelims, you can have tropical cyclones in South Indian Ocean. It can impact Indian monsoon. Yes, it can. So when we talk about coral reefs, here we will be talking about the types of reefs. You have different types of reefs. That is the fringing reef, the barrier reef, and also the atolls. Okay, these are the different types of reefs which are in existence. So here a question can be asked from this particular portion in the prelims and the mains both. Then after that, here you will also find questions with regards to coral bleaching. Coral bleaching, the reasons for it, and causes leading to it. Okay, so this is the area where you typically will find a question appearing in the mains and also prelims. Okay, so that is what we are going to be looking at purely from a geographical point of view, not from the portion of environment. That is something that we are not going to look at. We are going to look at it and address it purely from a geographical point of view. So when we talk about coral reefs in general, now these coral reefs, they are also referred to as the tropical rainforest of underwater ecosystem. They are also regarded as tropical rainforest of the marine environment. Rainforest of marine environment. And these coral reefs, they are created, or why are they referred to as tropical rainforest? First of all, here you will observe the vivid coloration that they have. That is where they are able to manufacture food. You have the corals, basically they are a symbiotic relationship. They exhibit a symbiotic relationship between the algal species, that is zooxanthellae, and the coral polyp, which is an animal. So this zooxanthellae carries out photosynthesis and produces oxygen. Produces oxygen due to photosynthesis. And then furthermore, here you will also come across a situation where it manufactures enough food to provide shelter to a large number of organisms. Hence, they are referred to as the tropical rainforest of the underwater ecosystem. Now, here, if you take a look at these coral reefs, basically it is an underwater ecosystem characterized by reef building corals, right? And they are formed out of massive colonies of coral polyps. So, individual coral is referred to as a coral polyp. Now, this coral polyp is ideally an animal. Overall, this is what is a coral polyp. Okay, this is what is referred to as a coral polyp. Now, in this case, you will observe that the corals have got the polyp has got tentacles. These tentacles are ideally present in order to capture any kind of food which is floating around in the ocean. They capture it, send it down the orifice into the digestive system, where then it is utilized. But then, obviously, the availability of food is not very significant floating around, because these corals, they are fixed to the ground. That is why they enter into a symbiotic or a mutually beneficial relationship with the algal species, that is zooxanthellae. So here you will find a kind of a symbiotic relationship, right, with zooxanthellae. So symbiotic relation with the algae, that is zooxanthellae. Now, zooxanthellae, what it does, carries out photosynthesis, and manufactures food. And that food is utilized by the corals. And in turn, as it carries out the process of photosynthesis, it also ends up produces oxygen. And meanwhile, when we talk about these coral polyps, they have the ability to synthesize the carbonate ions and the calcium ions which are present underwater, and they are able to manufacture a very strong calcium carbonate exoskeleton around the body structure. So that is where they will be able to form a very strong calcium carbonate exoskeleton. So here, when we talk about these coral reefs, this is a combination of multiple different coral polyps who have built that calcium carbonate exoskeleton, and they have basically cemented and stabilized in any particular area. The largest coral reef is the Great Barrier Reef, which spans close to around 1600 miles or close to around 2600 kilometers, to be found across the northeastern coastline of Australia, closer to the Coral Sea in general. Largest proportion of coral reefs you will find in the region of the island nations of Indonesia and Philippines. That is where the proportion of corals available and the coral reefs available is very, very high. Now, when we come to the growth of the corals, all these corals, they have got a very large lifespan, very long lifespan. Few of the corals can live for hundreds of years altogether. But when these corals die, they will leave behind the strong calcium carbonate exoskeleton that they had built. The calcium carbonate is a kind of a binding agent. That is what is utilized in manufacturing of cement and so on. So that calcium carbonate will be left behind as the corals, they end up growing. So that is where the older generation of the corals will leave behind the calcium carbonate. That will be utilized by the next generation of corals to build on them, and slowly and steadily they keep on building above that. Now, what that also means is that eventually they come closer to the surface. So, if this is regarded as the sea surface, here, let's suppose you have an underwater region, and on top of it, corals begin to grow, let's suppose. Now, after they have died, they will leave behind the calcium carbonate exoskeleton that will be utilized by the next generation of corals as they continue to grow. Slowly and steadily, you will observe they are coming above water. Now, eventually, as soon as they are able to rise above water, immediately the corals will die because these are marine species. And being marine species, they won't be able to survive over air, right? So, as soon as they come above water, these corals will die. Now, what they have formed in the process is a kind of a calcium carbonate based island, right? Which is also regarded as a coral island. Now, in this case, you have the white calcium carbonate. Now, that calcium carbonate will be disintegrated, will be broken down by the various different types of elements of nature. You have weathering events, other events of nature, which will break this down. Now, slowly and steadily, this will get converted into a kind of a sandy feature due to disintegration. Now, when you have the presence of an island, obviously, the birds which are moving across larger distances, they will take shelter. When they take shelter here, maybe they will drop a seed or two. And that is how you have the growth of certain kinds of plants or trees, which are observed in these areas. You will observe the growth of certain kinds of plants and trees. And that is how the entire region gets inhabited. So that is how many of the islands across the globe you will observe they are the coral islands. For example, take the case of Maldives. Maldives is a coral island. Take the case of Lakshadweep. Lakshadweep is a coral island. Havelock in Andaman Nicobar, that is also regarded as a coral island. So that is how the coral islands come into existence. Example, Maldives, many countries or many regions in the region of Western Pacific, many small islands that you have, Lakshadweep, all of these are examples of coral islands. Okay. Now, here, when we talk about these coral reefs, what is the brown color structure in reef diagram? Which brown color structure? Are you referring to this one, Vivek? Is that what you are referring to? That is the internal body of the coral polyp, my dear friend. That is the digestive tract of the coral. Okay. Here, observe this is the opening, the orifice, and that is where the food is ingested. Now, this is the spread and the distribution of corals across the globe. Majority of these corals, they are the warm water corals. And when we talk about the warm water corals, the conditions required, observe, this is where majority of the corals across the globe are to be found. In the shallower water areas, wherever the sunlight is available, that is where these warm water corals will grow. So when we talk about warm water corals, overall, the conditions required for the growth, conditions required for the growth. What are the conditions? Availability of sunlight, because zooxanthellae is an algae which works on the availability of sunlight, right? Because that is when the photosynthesis can be carried out. So shallow waters. And that means availability of solar insolation, of sun. Then you have temperature, stable temperature. around 24 to 26 degrees Celsius. Then clear saline water. That means no pollution and no sedimentation. Okay. These are the features required for the growth of warm water corals. All these indicate the warm water corals that you find across the globe. However, there are certain cold water corals also which are existent in colder areas, but significant research has not been carried out. The example of the cold water coral, if you think about it, the largest example is the Rost Reef near the coast of Norway. That is considered to be an example of cold water coral. So when we talk about cold water coral, so example, you have Rost Reef off the coast of Norway. Many such cold water corals also exist, but primarily we shall be concentrating upon the warm water corals because they are very predominant. Then when we talk about coral bleaching is what? Whenever you come across the term bleaching, bleaching is an English terminology. So when we talk about bleaching, that is when there is a kind of a whitening impact which happens. So here, when the adverse conditions they start to develop, in the presence of the adverse conditions, the zooxanthellae, their production that starts to reduce. Many of the zooxanthellae population they also die. Which adverse conditions? Let's suppose the sea surface temperature has suddenly risen. Let's suppose there is a lot of pollution which has been carried out. Let's suppose there is a spread of disease in that region. So anything can lead to adverse condition due to which the zooxanthellae population that dies. Now, once the zooxanthellae population is present, observe the vivid coloration of the corals. When it dies, you will observe a kind of a stony white appearance of the corals. The zooxanthellae has basically died in that case. And that is when you have the condition of bleaching. This is referred to as the bleached coral. Now, when the coral has been bleached, then it doesn't have enough food resources to sustain itself. That is where, let's say, the conditions revert themselves back to normal within 30 to 45 days. Then the zooxanthellae population will come back in that area. But if the conditions they don't revert themselves within 35 to 40 days, then these corals they start to die. And that means all the benefits that the corals were supplying to the marine system, that benefit is taken away. So here, productivity, first of all, you have adverse conditions. They lead to decline in productivity of zooxanthellae or the algae. As a result of that, zooxanthellae population dies. Now, if conditions are reverted or reversed within 35-40 days, zooxanthellae comes back, else the corals begin to die. Okay. So what are the conditions which lead to the bleaching of the corals? So the conditions which lead to the bleaching. So here you have certain set of conditions. For example, rise in sea surface temperature. For example, recently it was in news that the region of Western Australia, that is the Great Barrier Reef, that went through the fourth mass bleaching event in the past 5 years. Why? Because last 3 years consecutively were the La Nina events, which was also referred to as the triple dip La Nina. So when you have La Nina, you have accumulation of warmer waters near Australian coastline. So that has led to massive bleaching. So whenever the sea surface temperature rises, bleaching is initiated. Because the marine organisms, they have very low thermal tolerance. They are not able to tolerate any variation in terms of temperature. Then whenever you have events of, let's say, pollution, it can be marine disaster, it can be oil spill, it can be solid waste pollution, right? So oil spill, it can be solid waste, that is plastic, for example. All of that leads to bleaching. Then you have diseases, onset of diseases, bacterial and fungal infections, diseases. Then after that, you have unsustained fishing activities. For example, the bottom trawling. Bottom trawling is a kind of a fishing activity in which you attach a net to the bottom of your boat and that scrubs against the sea bottom, so sea surface, in order to catch the hidden fishes which are there. But in that turn, in order to do that, what they end up doing is scratching against the surface. Many of the corals, they get uprooted, and the situation and the waters become so muddy that the corals are unable to survive. So unsustainable fishing like bottom trawling. Bottom trawling. Bottom trawling is banned in India, but then it is still carried out in the region around Tamil Nadu coastline, which has led to a significant decline in coral population in the region of Gulf of Mannar. That is why oftentimes you will find that the Sri Lankan fishermen and the Indian fishermen, they are at loggerheads. Why? Because the Indian fishermen in many of the regions, they carry out bottom trawling, and that kills the corals of that region. That means the shelter for the fishes is taken away. That means a long-term decline in fish population. So that is basically the condition of coral bleaching. Now we come to the various different types of corals that we have. So corals, they are classified into three broader categories depending upon where do you find them. So before this, you need to have an idea that any land which gets created, that land eventually ends up sinking as well. Not always, but in many of the cases, you have, due to endogenic forces, particularly the aperogenic forces, you have the rise and the fall of the land typically. So let's say a new land is created due to volcanic eruption. A volcanic island is created. Now, slowly around that island, you will observe along the fringes or along the corners of the island, you will observe the development of a reef like structure. That is what is referred to as fringing reef, right? That is what is a fringing reef. Now, let's suppose after a few thousand years, this particular island starts sinking due to an aperogenic force or an endogenic force. There's a subsidence, let's suppose. Now, as it starts to sink, the corals, they are left behind where they are. So it forms a kind of a land surrounded by corals like a barrier. That is what is regarded as a barrier reef. So in the case of the barrier reef, you will have a lake, a lagoon of sorts in between. Then eventually, let's say this subsidence carries on further and the entire landmass sinks, you are left with nothing but an island of corals. That is what is regarded as an atoll. So these are the three types of coral reefs depending upon where they are found. So when we talk about fringing reefs, they are formed along the coast of the continents or islands. Their surface is connected to the coast and rises up to the low water tide level as rugged and uneven platform. So this is basically your fringing reef. This is where you have the presence of fringing reefs. Okay, so majority of the reefs that you observed in the map, all these reefs that you observed here, these are examples of fringing reefs. The reefs that you observe here, these are your examples of fringing reefs, all of them, which is closer to the coastline. That is your fringing reef. Now let's suppose the land starts subducting. So then you will have water which comes in between the land. Observe here, water has come in between the land and the coral. And this coral forms a kind of an island of sorts. So here water has come in. So this is what is regarded as a barrier reef. Example, the Great Barrier Reef of the coast of Australia. So observe the coral reef in this region. Here you have barrier reefs in existence. Okay. Then after that, if that land also sinks down, you are left with nothing but a kind of a coral island in itself. A kind of a coral island itself. So that is why here observe this image. This is the water surrounding that. This is the water here that is represented here. So here you will observe it suddenly gets very, very deep. But in between here in this region, it will have a shallow water, a kind of a lagoon of sorts. So observe the whitish portion. So that is basically, imagine that at one point of time, land would have been present in that region which has now sunk. Now this you will be left with small island shapes all around, right? That is an atoll. So in the case of the atoll, you will, or even in the case of the barrier reef and fringing reef also sometimes, you will come across very whitish, a turquoise blue kind of coloration pattern of the sea. And that is not because the water is particularly clean and clear here. That is because the corals, they are primarily made up of, or they have the exoskeleton made up of calcium carbonate. Calcium carbonate being whitish in appearance, that is what reflects light, and that is why the water here appears so blue, turquoise blue. Here the water is appearing dark blue. Why? Because the light is penetrating to the bottom, right? And here light is reflected by those calcium carbonate. That is why you will come across various different images, not only on social media, but also on news headlines, where you will, if you take a look at islands of the Pacific, you will find that the water is absolutely bright blue. For example, if you take a look at Maldives, you will find that the water is absolutely bright blue. And you might be wondering that why is it that when we go to a coastal area in India, let's say in Goa or in Chennai, water is so dirty, but in these parts of the world, water is so bright blue. That is primarily because when we talk about the coral reefs, these coral reefs eventually they have calcium carbonate, and calcium carbonate is whitish, which reflects light, bringing that kind of a colored appearance. Does not mean that the water is very bright blue. Okay, so that is the case of an atoll. You will find many such atolls in existence across the entirety of the region of Western Pacific. Western Pacific is dominated by the corals, and that is where one third of the corals, warm water corals across the globe, you'll be able to find in the region of Western Pacific itself. Why? Because there you have thousands of islands which are in existence, and all these islands, they will have the shallower waters near the coastline, so natural development of the corals will occur in that particular region. Similarly, when we talk about Maldives, Maldives thrives on tourist money. So that is where in Maldives you'll find a lot of these corals in existence. Okay, now this is basically a schematic representation of how an atoll gets created overall. So when you take a look at an atoll, basically, let's start with the formation of the landmass itself. So when the land gets formed, it rises above water, you have the formation of an island of sorts. So initially, the corals will start developing on the side of these. So that is the stage of fringing reef. Fringing reef. Then after that, let's suppose the land starts to subside. These reef structures will be present in the region itself, but the land in itself has subsided, so water comes in between. This is a condition of a barrier reef. And eventually, when the entire land has subsided, you are left behind with nothing but coral islands, and these are what are referred to as atolls. So corals basically are very beneficial in general. Now these corals, they manufacture food, they supply oxygen to the underwater environment. Now the food that they manufacture, they provide in the form of the zooxanthellae, that is the one which manufactures food eventually. So that food provides a lot of nourishment for host of various species underwater. Many of the species you will find moving around in the region of these corals, right? So here these provide fishing activities. Now, in these areas where you will find corals, a lot of tourism activity also happens. So, a lot of income from tourism. Also, these corals, they provide a kind of a buffer to the coastline. So, for example, if let's suppose this is the coastal area, and here, if let's suppose this is where the water is, the water level. Now, generally, when you talk about the corals, you'll find the corals somewhat like this, growing like this. Okay. So what do you observe here? That these corals, they have the ability to break the waves. So they protect the coastal area from storm surges and even tsunamis. So corals break the waves, and hence they protect the coastal areas from the impact of storm surges and tsunamis, which are generally otherwise experienced. Nowadays, these corals are also being researched for medicinal purposes and drugs, which can be used for to cure various different types of diseases. Okay, so that is basically the geographical aspect of corals that one needs to be aware of. Okay. Now, after this, we come to the portion of Indian geography. But before that, we'll take a break. Utkarsh, why do Australian region have so many reefs? Not only Australia, in fact, more than Australia, you have Indonesia, Philippine region that has got many amount of reefs, and that is basically why, because there you have endless number of islands providing the shallower waters where the reefs can grow. Yes, the same work is carried out by the mangroves as well in terms of protection of the coastal area. So now we come to the portion of Indian geography. We'll initiate the discussion from the location of India, also the geostrategical advantage that India has owing to the location, the origin of various different parts of India, the formation of various different parts of India. All of that we shall be doing after the break. So we take a break right now, and we will be getting back with a new link at 6. Okay, till 6 p.m. Have a break, get back, hopefully refreshed, and then we'll initiate the discussion of Indian geography.